Your injection molding machine is running perfectly. The material is spot on and the mold, top quality. So why are defects still showing up? Cycle times are creeping up, rejection rates are climbing, and worst of all, your machine is becoming unstable. What if the problem isn't your machine at all? What if the real issue is something you've been overlooking? Your cooling system. Today, we are uncovering the hidden hero of your entire operation, the cooling tower. The one system that quietly controls your production speed, machine stability, product quality, and ultimately, your profits.
In injection molding, the most critical stage isn't filling, it's cooling. Once molten plastic enters the mold, it needs to cool down and solidify properly. And what makes that happen? A chilled water system. Now here's where it gets interesting. The cooling tower plays a key role. Its job is simple. Take hot water from the system, cool it down, and send it back for reuse. But how does it actually remove heat? Through evaporation. It releases heat into the environment, keeping the entire system stable. In simple terms, a cooling tower is a heat rejection system that transfers unwanted heat into the atmosphere using evaporation. Remove heat, stabilize your system. Stable system, better quality plus faster production. In injection molding, the most critical stage isn't filling, it's cooling. Once molten plastic enters the mold, it needs to cool down and solidify properly. And what makes that happen? A chilled water system. Now here's where it gets interesting. The cooling tower plays a key role. Its job is simple. Take hot water from the system, cool it down, and send it back for reuse. But how does it actually remove heat? Through evaporation. It releases heat into the environment, keeping the entire system stable. In simple terms, a cooling tower is a heat rejection system that transfers unwanted heat into the atmosphere using evaporation. Remove heat, stabilize your system. Stable system, better quality plus faster production.
Inside an injection mold, specially designed cooling channels allow water to circulate continuously. But here's the catch. If that water isn't cooled efficiently, everything starts to suffer. The mold begins to retain heat. Cooling slows down. Cycle time increases and product defects start to appear. This is where the cooling tower plays a crucial indirect role. It helps maintain stable mold temperature, faster and uniform cooling, higher production speed, and most importantly, better product quality. So while you may not see it directly, the cooling tower is a key player behind every perfect molded part.
Now let's look at a practical example. Imagine your cycle time is 30 seconds, but your cooling system isn't efficient, the mold isn't cooling properly, and suddenly your cycle time jumps to 40 seconds. Now watch the impact. In just 1 hour of production, at 30-second cycle, you get 120 shots. At 40-second cycle, you get only 90 shots. That's a straight 25% production loss. And if your plant is running 24 hours a day, just imagine the scale of that loss. This isn't just about seconds. It's about productivity, efficiency, and serious money on the table. Now, what happens if your cooling isn't proper? Let's look at the kind of defects it can cause in your product. Warpage, the part starts bending or losing its shape. Sink marks, surface depressions begin to appear. Shrinkage variation, inconsistent material contraction. Dimensional inaccuracy, parts go out of tolerance. And the reason is actually very simple. Uneven cooling leads to uneven shrinkage. That's why the cooling tower plays a critical indirect role. It acts as the backbone of your product quality. If your cooling is stable, your quality is reliable. If not, defects are inevitable. So far, we've talked about mold cooling, but there's another hidden role of the cooling tower inside the machine itself. The first and most critical point is feed throat cooling. The feed throat is the area where plastic granules enter the barrel. Around this section, there's a water jacket through which cooling water continuously flows. Now, what happens if this cooling isn't effective? The granule starts softening right at the entry point. Material begins to stick together. This is called bridging, and feeding to the screw becomes unstable. And the result? Short weight starts fluctuating. You get short molding and inconsistent parts. Let's take a practical example. If you're processing materials like nylon or ABS and the feed throat cooling is weak, the material can start melting right at the throat. The screw doesn't get proper consistent feed, and ultimately your machine loses stability. So remember, feed throat cooling may look like a small detail, but it has a huge impact on process stability and product consistency.
Now let's move to another critical system, the hydraulic oil cooling system. In an injection molding machine, hydraulic oil continuously generates heat due to the pump, the motor, and the valve system. To control this heat, a key component is used, the heat exchanger, also known as the oil cooler. And this is where the cooling tower plays an important role. Cold water coming from the cooling tower passes through the heat exchanger and removes heat from the hydraulic oil. But what if the cooling tower isn't efficient? Oil temperature starts rising, oil viscosity begins to change, machine response becomes slow and sluggish, and the life of valves and seals reduces significantly. So remember, efficient cooling isn't just about the mold, it's also essential for maintaining machine performance and reliability.
Let's understand this with a real practical example. Under normal conditions, hydraulic oil temperature stays around 40 to 45 degrees Celsius. But with poor cooling, it can rise to 55 to 60 degrees Celsius. Now look at the impact this creates. Injection speed becomes unstable, clamping pressure starts fluctuating, cycle repeatability gets disturbed. And here's the critical point. Even if your mold is perfectly designed and built, the machine will still fail to deliver accurate results. Because in injection molding, it's not just the mold. Machine stability is equally important for consistent production.
Now let's talk about the most important factor, profit. If your cooling tower isn't performing well, mold cooling gets affected, feed-through tissues start appearing, hydraulic oil begins to overheat, which means just one weak system can create multiple problems. Product quality drops, machine becomes unstable, production slows down. And the loss? It's not single, it's triple. But now look at the other side. If your cooling system is strong and efficient, faster production, better product quality, stable machine performance, and ultimately, higher profit. So remember, a cooling tower isn't just a utility, it's a profit multiplier.
Let me share a real factory case. There was a persistent problem. Parts were showing warpage and the cycle time was unusually high. So the team tried everything. They changed the machine, they even changed the material. But the problem didn't go away. Finally, they decided to check the cooling system. And that's where the real issue was found. Here's why. The cooling tower was blocked due to scaling and the water temperature was too high. As soon as proper cleaning and maintenance was done, cycle time dropped from 35 seconds to 28 seconds. Rejection reduced from 12% to just 3%. Problem solved. See, sometimes the issue isn't in the machine or the material. It's hidden in the cooling system.
In the industry, people often make some very common mistakes. Choosing an undersized cooling tower, ignoring regular maintenance, overlooking scale buildup and algae formation, not following proper water treatment practices. And then they say, there's a problem with the machine. But the reality is, these small mistakes quietly create big losses, reduced efficiency, poor product quality, higher downtime. So don't ignore the basics, because in cooling systems, small negligence can cost you big. If you want the best performance from your system, you need to get the basics right. Use a cooling tower with the right capacity. Follow regular cleaning and descaling. Apply proper water treatment chemicals. Keep a close eye on temperature monitoring. And always maintain the correct flow rate. These may look like simple steps, but their impact is massive. Better efficiency, consistent production, higher reliability. So remember, simple actions can deliver powerful results.
In injection molding, it's not just the machine and the mold that matter. The cooling system is the real game changer. If you truly want to improve your production efficiency, product quality, and machine life, then you need to take your cooling tower system seriously. And remember, if your machine is overheating, a simple fan is not the solution. The real root cause could be your cooling system. A cooling tower in injection molding is not just an accessory. It directly influences the mold, it stabilizes the machine, and it controls the material behavior. Ignore it and you're putting your entire production system at risk. So if you want more practical industrial insights like this, subscribe to the channel and share this video with your team.